Hello, today we're going to talk about motion. And the big ideas with motion is how things move, and we're going to record and calculate and find out object speed and acceleration and also deceleration as well as momentum. But our today's topic is primarily about frame of reference, displacements, and also calculating velocity and speed. All right, so our first item we're going to focus on is actually a frame of reference. And a frame of reference is an object that you are relating how things move to. For instance, if you're on the side of the road and you see a car move by you from left to right, then the frame of reference for you is that fixed point, you standing there and you're seeing the object move. The largest frame of reference is actually the Earth, and with us spinning. Another one is displacement, and displacement is you want to find out how much distance actually was moved or actually traveled by an object, going from starting to ending. Let's look at it this way. At the fair, have you ever ridden one of those rides where it takes you around, little Ferris wheel, or a ride where it takes you around the whole area of the park? Well, if you start on the ride and you go to the other end, you can get out and you can actually measure your distance. But what if you stayed on that ride and you went from point A all the way back to point B? You went back where you started. The actual displacement at that point is zero because you haven't traveled anywhere. You felt like it riding the ride, but you ended up where you started. So therefore displacement is zero. Now we're going to work some problems in a few minutes on displacement, but I wanted to go through the actual information here. So on here it has to have a direction and you have to cover a distance. So when you have several displacements, let's say this little girl right here, when you travel 1 meter up, 2 meters north, then all of a sudden she turns east 1 meter and then goes another 2 meters and then starts to head south 3 meters and 3 meters and then heads back west 3 meters. When you calculate it all, it ends up where she's zero. This is sort of like that amusement park ride where they travel around and end up here. But let's say I travel to the mall, and it's 10 miles to the mall, and then I continue heading east of here from South Central. I keep going east to my home, which is a continuation of east. Then I would just add the two. But let's say I went from South Central to the mall but headed back to South Central, I would subtract the two. But if they're going in the same direction, you add, and if you're opposing the two, then you subtract. If they're opposing directions, then you subtract. Okay, here are some examples of combining displacement. Here's the first problem. My ball was kicked 10 meters, right here, 10 meters, and then it was kicked east 5 meters. Both of these directions are both going east. Because they're both going east, we want to know how far and what direction is the ball moving from the beginning. So when we look at this one, they're both going east. We're going to add them together. So 10 plus 5 equals 15. And the direction is east on there. Okay, problem 2 said Sarah ran 20 meters north from her house. Before turning around, she ran 5 meters south. Okay, so 10 meters north, 20 meters north, 15 meters south. Because they're opposing, we're actually going to subtract it. So 20 minus 15 is 5, and you go with the direction of which one is larger. 20 is bigger than 15, so therefore you stick with that direction, north. So it is 5 meters north is the displacement. All right, speed. I love the movie with Speed with Keanu Reeves. And I was trying to think of another movie where I feel the need for speed. I think that's in Top Gun. I'm not sure, but I'll figure it out. But I love that. Maverick and some of the other, I forgot his name. Which one? Iceman, Goose, and yes, they're all in there, and they're loving speed because they want to fly those planes at top speed. So speed is this. It's a rate of motion. You're changing your position over time. Now, when we calculate speed, here's our formula. It is distance, whatever distance you travel, you divide it by your time. This is a rate problem. Maybe in math you've related to rate problems. Rate problems always have time at the bottom. Here is our triangle. So when we add it in there, D goes on top and S and T go at the bottom. So your speed, S is speed, D is distance, and T is time. The units for these, the distance is in meters, the time is usually in seconds, and the speed would be meters per second. Okay? Now, we also have an average speed versus instantaneous. So when you think of instantaneous, big word here, this is happening now. Instant, right now. Break it down, vocabulary words. When I look at average, think of your grades. I have to average them for you. And I'm going to calculate it, and actually I'm going to go the furthest distance, the total distance divided by your total time. And in most instances, it's the biggest distance divided by the biggest time. Here's an example of a speed problem. Alex rode his motorcycle 600 meters in 15 seconds. All right, now let me get my pen out so I can draw. Remember, I like to draw my triangle. Okay, it's kind of weird here, but that's okay. It's my triangle. All right, so remember, D goes up top. S is down on the far right. It's a pitiful S there. And this is my time. Okay. All right, so here we have 600 meters. That's a distance. So we're going to put 600 up at the top. Now I'm going to go back and make that 6 a little more defined there. There we go. 600, and we're going to divide it by 15 seconds because the 15's down at the bottom. Okay. So using your calculator, you take 600 and I'm going to divide it by 15. And when I calculate it, I get 40. Okay, I get 40. And I need a unit. Distance is in meters. Since it's up top, we're going to put it on top. Over meters per second, because the time is down on the bottom. So the answer is 40 meters per second. All right, so here's another one. What is the average speed of a car that the graph is representing? Now remember I said with average, when you see this, when you're going to take the graph all the way up, and you're going to go to the, whoops, let me come back to that slide. You're going to go all the way up. So my highest distance right here at the point, let me get the pen color going. Let's go with red. So at this point right here, we're going to take the data collected. Over here on the vertical axis is your distance. And when I travel it over, it goes up by 5. So that's 10, 11, 12. So it is at the 12 mark. Okay. Right there, and then come down, and then our time is at the 4 seconds. So if I want to know average speed, remember distance, this one, 12 divided by 4. And what's 12 divided by 4? The answer is 3. And I'll try to work this one on the board after the video. Velocity. Velocity mathematically is the same thing as speed. Is the same thing as speed, but all we're adding here is a direction. So are we traveling 15 meters per second north, south, to the mall, to Miss Clatch's house, to Miss McClung's house? It will be one of those. All right, so here's the formula again. Exactly. Distance divided by time. Same thing. distance, time, but instead of S, we're going to put a V there. But mathematically, it is the same formula. All right, so at this time, we're going to break. We're going to practice a few problems with these. Then we're going to do a lab, a walk in the park. Have a great day.